So in the Rocchio's algorithm, what we do is, here we given an initial query or an original query QO, we modify its vector in the vector space model. How we are modifying it? We are basically modifying the original query vector by the difference between the relevant basically the centroid of the relevant document and difference between centroid of the relevant document and the centroid of the non-relevant document. And we are not actually directly computing the difference. We are applying one parameter here, beta and gamma, which tunes the importance that we want to provide on this individual individual known set of relevance and known set of non-relevant document. So an obvious question that we started discussing on is basically what should be regarded as a set of non-relevant document. So if we select marked non-relevant documents from the pool, the pooling that we have discussed earlier, it can be the case that we will be having too little information, because let's say in the collection we have say 1 million document, and in the pool length will be what, maximum will be say 10K. It's much less. So if we only mark the document and mark the non-relevant document from this pool, it will be too small information as compared to the entire collection, because all these documents, all the rest of the documents, as we have discussed, they are considered as non-relevant. So if we only consider the pooled document, judged pooled document as a gold non-relevant document, this will be too little information. And there will be multiple documents which are inside this corpus relevant. So if we consider all the documents, or basically if we consider this as the collection C and this as the pool, and say among this, this is the set of relevant documents. If we consider the rest of this set, rest of this portion as the non-relevant document, so it can be the case that there are multiple documents which are actually relevant but which are not actually participating in the pool. In that case, unseen relevant document can actually hamper the vector modification. So as we have discussed, we need to set beta and gamma accordingly. Usually we set the value of gamma to something very small, and we set the values of beta based on the number of relevant documents that are marked. So basically, after selecting a set of documents to be considered as the expansion term, or as to construct the modified query vector, we can rank the terms by the number of relevant documents they occur in from the relevant document set DR that we have already discussed, and add say 50 or 100 terms while modifying from QO to QM, the modified query. Okay, note that it can be the case that QO was containing say Q1, Q2, Q3, say three term query. For QM, it can be actually a 50 term query or more than that. So basically, the traditional way of doing this is basically add 50 or 100 terms with the initial or the original query. So what could be some problems with this model? So usually, this is expensive with respect to time. Why? Because here in this model, we need the set of DNR explicitly marked by the user. And of course, users will be reluctant to provide this kind of a feedback. If we ask the user after performing a search to mark some of the documents as relevant and some of the documents as non-relevant, the user will be feeling reluctant to even use the retrieval system anymore. We can consider this from the scenario of simple Google search. Let's say if we perform a Google search and every time after performing a search, Google is asking for our feedback. So definitely we will not be using Google as much anymore. So this kind of a feedback, which is explicit feedback that we are using to construct this DR and DNR, the set of relevant and non-relevant document, this kind of explicit feedback is actually expensive to actually get, to form.